Alright guys, let's start course C. My name is Marcin. Jim and Hugo will be helping me and you with completing this course. Hugo will take care of the workshop part, and me, I will be mostly available for you to ask questions. If you've got a question, just raise your hand. So let's start. Hugo, please. Thank you. Developing apps with IPFS APIs. We want to think about using IPFS as a building block in your application. And we got application right there. It's a very simple application. It shows you peers that are connected, that have this page loaded. And you've got some files, you have pictures, you've got some data about each peer that's connected to that board. So how do we build a simple app like that? So the goal of that small sandbox application is to build a basic understanding about IPFS in apps. And to do that, we need to be able to answer basic questions like where to run it. Is IPFS running on that page, or is it running somewhere else? And we talk to it by some means. What to run? Is it js-ipfs? Is it go-ipfs? Is it the client of some API? How to talk to it? Is it embedded node that we talk using programmatic interface? Or is it a remote node that we talk to over HTTP API? Finally, how do we store data? How do we add a picture to IPFS? And how do we get it back when someone else is publishing it? And speaking about publishing, when people want to publish a picture and then we publish another one or change the description, how do we track updates? And we will be using IPNS for it. Let's talk about provisioning, which is basically a fancy way of talking where to run IPFS. There are two high-level patterns when you want to use IPFS in your apps. Every app has a variant of one of those two. First one is when your application is embedding API client. So your app does not have IPFS inside. Your IPFS is running somewhere else. It could be the same machine as a separate process and a separate user in the security sandbox, or a remote node somewhere in the cloud infrastructure. And your app talks to the IPFS node over that API. Second pattern is when your app and IPFS node are one and the same. Your app embeds IPFS node and is effectively part of the swarm. Let's talk about IPFS as a backend service. When you run IPFS as a backend service, it acts, behaves basically as any other service you would run on your cloud infrastructure, like a database, a load balancer. You can self-host it. You roll your own infrastructure by installing go-ipfs. You can pick pre-built binaries or build full sources. There is also a Docker image. If you have bigger needs, such as your data set does not fit on a single node, or you want more advanced features for managing pin sets, you want to ensure there are multiple copies across multiple nodes, then you want to deploy IPFS cluster on top of go-ipfs nodes. That will give you more advanced features. And we won't go into that because there are entire courses on this today. So if you are interested in deploying IPFS infrastructure based on go-ipfs, go to elective E. It's today, after this course. And also, if you want to learn more about IPFS cluster, there's elective B, entire course about this. And I did told they have a pretty cool visual demo, so make sure to check this out. Of course, you don't need to run your own infrastructure. You can pay or use someone else's. And there are cloud providers that give. Sorry about that. cloud providers that give you some either free access to free services such as Cloudflare Gateway, or basic pinning services when you get some free space to experiment, and then you can decide, do you want to continue paying people or run your own infrastructure. And even Microsoft provides a privacy-centric version of IPFS, which you can create an embedded private swarm. So you can run it on the cloud, but also you can embed IPFS inside of your node, and it will ship with your app. We can embed go-ipfs. Example of that is IPFS Desktop and Bazaar. Technically, run a local node and the app talks with over HTTP API, but it's like in practice, it's effectively embedded. Textile Photos is a good example of a mobile app which uses embedded go-ipfs, and there's entire elective team about building distributed apps with Textile SDK. And of course, you don't need to embed entire go-ipfs binary. You can make your customized build, and there's a pretty cool example of IPFS Lite, which can be used for just fetching some blocks and putting some blocks on network without any additional features. You can also embed js-ipfs, and you can embed it in any web browser, and in any web context. That could be web browser, that could be Electron app, or just a node application. When you run it in a web browser, you need to understand limitations around transports and discovery methods. I think Core Course B covered a little bit of that. But for this exercise, especially for that app that we'll be building, we need to understand that there are differences in transports available for js-ipfs and go-ipfs. For js-ipfs, there are differences between js-ipfs running in web browser and running in Node. So if you run Node or Go version, you have access to TCP transport. However, in browser, it's impossible to establish TCP connections. We use WebSockets in that context, and luckily you can enable it in Go after setting up certificates. So that way you get a full transport coverage across both implementations in all three runtimes. So WebSockets are a good default. WebRTC lets you establish direct point-to-point connections between browser and nodes, and there's work in progress for Go. And also Go has a experimental quick transport that you can enable and play with. We hope to see something here for browsers, maybe related to WebRTC at some point, but this is the current state. WebSockets are probably, let's say, default for now. What are other differences? That's a lot. However, the takeaway from this basic course is that you use go-ipfs in backend contexts when performance or additional features are meaningful for you. js-ipfs is a default choice in web browser and anywhere where we would work with JS or don't need one of those additional features. There's a huge interval between both. The protocol level, the API is the same. Transports overlap in multiple contexts, and local discovery works as well. And soon we will have DHT. For now, js-ipfs does not have a DHT. That is why during the course you will see how we are using a signaling server to work around that, to discover each other. Let's talk about APIs. IPFS comes with IPFS command line interface, which is IPFS command. And you can use it for interacting with your local nodes. And during this course, we'll use some of those commands. The list is much longer. It did not fit on the screen. However, the same API is exposed over HTTP. So that means when you start IPFS daemon, it will announce itself on multiple ports for other nodes to connect. And it will also open an HTTP port with API. There's a separate port with gateway, which you can think about like a read-only simplified safe API. We will talk about gateway later. So I won't go into that. I will just show this simple example. You got a IPFS command executing ID, which will return you basic information about your node, your peer ID, your addresses. You execute that like this, and it will show you details about your local node. However, IPFS command is also a HTTP client for our API, so you can point it at any other API endpoint, and it will execute the command there. It's HTTP client, so you don't really need to use this command if you don't want to. You can use any HTTP client as long as you ask the proper path and the proper port. You can use it. I think there was a poster session yesterday. And those constructs give us an interesting possibilities. So let's say you have IPFS running somewhere in the cloud infrastructure here, and your app is connecting to it over API, HTTP API, and connection breaks. What happens then? You can build fallback when your app automatically spawns embedded js-ipfs and continues in seamless fashion. And an example of that is IPLD Explorer. It's at Explore IPLD.io. It's a simple application. It does not care about identity of your node. You just want to get some blocks from the network and show them to the user, which is pretty cool demonstration of this. It tries to connect to local API if you are running it and you allow it to connect. If not, it will transparently fall back to embedded js-ipfs, and you will still be able to access the same assets and explore them. And now we are moving to the demo application and the practical part of our course, and Hugo will tell you all about that.
Hi everyone again. So let's try to build a demo app. It will be something like what you see on that screen, and we'll be doing some light coding. It will be really simple. We have like 6 exercises and the last one we'll have the full app working. Hopefully everything goes well. So I'm going to ask you to get the template for the demo app. Go to this URL. You will have there a link to a GitHub repo, and I want you to clone that repo and basically run npm start and open also your text editor on that folder. You also have the link up there.
And then if you have any question at any point, just raise your hand.
So the state that I want that everyone has, it's basically this one: a browser with a web app loaded, and then the other side, your text editor on the first exercise. So if you have any questions, please raise your hand, and we will help you. Okay, guys, are you able to do npm start and get to this page? Yeah, everyone? No one needs help? Got it? Yeah? Cool. So let's go into the first exercise. So what we are gonna do now on exercise number 1 is basically connecting using the API. Using our HTTP client, we'll connect to a remote node We have one running here. Jim is running it on his laptop. And the important bits here is that basically we have the daemon running, we have an HTTP API, and we are going to connect to this address. So let's try to do it. We have also some resources with the documentation for the HTTP API and also for the client itself. Okay, so the exercise is really simple. This first exercise basically is already done for you, but how this works is it's basically like this. You will have some comments on every file, like this one. We have to-dos, and to-dos, 3 on this file. And below each to-do, you will always have a link. This will take you to the documentation, so you can look a little bit into it, and basically what we need to do is copy-paste whatever is in the documentation, just so you get the feel about how this works and how our documentation works. On this one, the first to do is tells us to add a script at loading the HTTP client that basically loads the browser bundle for the client, and that's already done here. But if you go to the link, you'll get instructions to do exactly the same. And on this one, the second to do, what we need is to connect to that daemon. So here we still need to do something because this IP in this port is wrong, right? That's not the same as you can see on the other screen. So let's try to change the IP and change the port and see what happens. Let's click on exercise 1, right over there, and then let's change the IP. Okay, the port is also wrong, so it's this one. Then you save it, should reload, and yeah, we have what we need. So the last to do on this exercise is to use HTTP client to find the remote daemon ID. So basic ID is some basic information, the daemon is listening on, the ID, the public key, the agent, the protocol, and stuff like that. We also have the documentation, and we call the command like this. You can use callbacks or promises, and it's really, really simple. Anyone has any questions for this first exercise? Everyone did it?
What is this IP address for? I mean, is something wrong with using your local host? Is it?
Sorry, what?
Is there anything wrong with using local host?
We are connecting to a remote host. That one.
Yeah.
So you want to, what's your question?
Why do we have to use that particular IP address?
Because that's the IP of our daemon.
Yeah, but I have a daemon running locally, so I can't use that.
Oh, okay, so you want to connect to your own daemon?
Well,
Yes.
what you usually do by default if it's running.
It depends on your use case, so you can do.
Yeah.
Do you know how to set the course headers on your Go daemon?
No.
No? You want me to explain it to you?
Okay, I'll just do that.
Yeah? Okay, so if you have, we can continue that conversation after. So, let's go into the second exercise, which is basically doing the same thing, but using the embedded JS daemon. We will be replacing the HTTP client with the embedded js-ipfs. We have some resources if you want to look at it. Or we can just go into the exercise number 2. You can always go back if you click on the title. You can go to the exercise number 2, and you go to the second file, which is called embedded API.html. So exactly like the first exercise, we have some to-dos, we have some links to the documentation, and this one is not already filled. So we need to do it. So the first one, you already saw how that works. You need to go to that link and get the URL to create the script tag on the first, right up there. Go to the link and get the URL to the browser bundle. Copy paste it into the file, and then we will go into the second to do. Okay. So now we have the script tag. Again, if you have any problems doing any of the to-dos, just raise your hand and we will help you. So we get the script tag. After this, we need to go to the second to-do, which is basically initializing and configure the JS daemon. Here we have one big difference between the client and the daemon, because in this exercise we are running the full node inside the browser, and we have some limitations in transport in the browser, so we need to use a signaling service so the browser can talk with the network. And as you can see, we have a little package called WebSocket Start that basically does signaling, so each browser connected to it knows about other peers in the network. And we need to use this one in the configuration, as you will see in a bit. And this one is run by Jim Pick, right over there, in his house in Vancouver. So the point here is that anyone can run these signaling services, and it's easy to do. There's not much logic inside of it, so it's really simple. So let's go into the second to do. We have two links here. Let's click on the second one because it explains to you both initializing and configuration. So right here, we have configuration to the signaling service, and you can just copy it over here. We're not going to use this one. We're going to use js-ipfs. We save it, and we can already see peers. So we are connected to the network. Anyone needs help? No? Yeah.
So okay,
Jim, can you help out there?
so we have this configuration. So where can we get this
You can always follow the code or look at the screen and just copy what's written in the screen.
There's no codes.
If you didn't connect to the signaling server, would you not be found or not find others, or both? Both.
Referring to that.
So if you didn't do that and you ran like swarm peers, you would get an empty list.
Yes. Yeah, there's no transports that's allowed to do that to the browser. Even if you think about like WebRTC, the protocol itself, you need signaling service, so you after can upgrade to a direct connection. That we have the same problem in IPFS or P2P in this case. There's just no like this. We only have WebSockets or WebRTC, and if you don't know where to connect, you can't even announce yourself, like, I'm here, you can connect to me, there's nothing in the browser.
It's different than the documentation.
Okay guys, while LiveLMG help out, let's do the last step, which we can actually just go to exercise number 1, copy, because it's exactly the same thing, it's the same API, it's the same interface, go to the second one, and just paste it in here, and hopefully we will get something there. Yeah, cool. So we have another difference here, which is this event, right? On the HTTP client, there was no event because we were connecting to a remote server. The remote server is already running. It already started accepting connections and announcing itself in the network, and everything is already running. In the browser, when we run a full node, a full JS node, in the beginning we need to wait a little bit before calling commands. Actually, this command doesn't actually need to wait for this event, but just for the purpose of explaining how the complete API works. Normally, we need to wait for this event, just to make sure that the network layer is initialized and at least we are making the first connections and the first discovery of new peers in the network. Okay, are we good until now? Yeah, you managed? Nice. So, IPFS, right? It's a file system. And being a file system, we should be able to work with some data, with some files and stuff like that. So that's what we're gonna do in the next exercise. We have the files API, which is basically IPFS add, IPFS cat. Yesterday you had some courses that hopefully explain to you how this stuff works, and you're going to use that the first API. But for more complex structures, you can also use the DAG API. The DAG API is basically IPLE. I don't know if you know what IPLE is. There's been some posted sessions yesterday. There's going to be a deep dive today, but yeah, we're not going to go into it, but it's there. You can learn more about it. You can ask us after about it. So let's go into an exercise about adding files. How adding files works? You basically run an IPFS add command, which works in the terminal, works as an API. You can use HTTP client, several ways to use the same interface. And if you add a file, you get a CID, a content identifier, right? And if you run the API, you get the same thing, plus a name, plus a size. There's the documentation here. Let's try to do it in our exercise. Challenge 3. And basically, in the challenge 3, the only thing we're gonna need is that first line. So as I told you, this accepts callbacks or promises, and when you use promises, you can also use async await. If you know about JavaScript, if you don't worry, it's really simple. You only need to copy that line over there to get the CID. So let's try to do it. Let's go back. Let's go into exercise number 3. Let's get the third file, which is named add file. And as you can see, everything you did before is already there, and you don't need to worry about it. You have the script tag, you have the singing service, everything with the node is already configured. You have the ready events, and now we only need to care about this part. So again, to-do link for the documentation. Go into the documentation and let's figure out how to add files. The documentation explains what you can input. You get all the options, lots of information, and also right here you get some examples on how to add files, right? So the line we need is this one. Let's copy it. Right here. And if you look into the documentation in this part, this is how the output looks. So it's always an array with all the files that the CID points to. Can be just one, can be multiple ones. So we get an array. So we need to assign this value to the CID, right? So we have the results. You can see it in a console log if you want. Just don't forget to add the S or remove the S. Let's just make sure it's right. And now, if we go back to our little hub, here we need to do results. We have an array, want the first one, and we want the hash, CID. If we save it, hopefully, what's wrong? Can you figure out what's wrong? I forgot to tell you about something. So I just copy pasted, and that's exactly the problem with copy paste. Some typos, right? Our input's called file, we have files here. And I want to tell you a little bit about file. That file there is a DOM file object, and we also support it directly here. So we don't need to go around and transform your files if you are doing an upload thingy like we are doing now. So let's just remove here. Okay. And let's try to add the file. Okay. And we get the CID. Right? Can you follow? Do you have any questions, any problems? Raise your hands. Just try to follow the coding screen. You need some help. Yeah, go into the editor. Let's figure out what's wrong. Type results. Okay, so now let's go into reading files. It's basically the same thing, but in reverse, right? We have a simple command, IPFS cat, pun intended with rest cat. And if we already added a file, we get a CID, and we pass the CID to the cat command. And we get the file back. Same thing, using the HTTP API, or as we're gonna use in the browser, calling the programmatic interface. Also, there's another option to load content. When you run your daemon, you can see that this line over here, which is the gateway. The gateway allows us to easily, it's a read-only API just to load nothing else, just to load the content. If you know the CID, you can use this the IPN port, and you can build your URL, basically IP port slash IPFS slash CID, and you can see whatever the content inside the file. And you can just load it in the browser. Just like that. So let's go into challenge 4. And yeah, again, the only thing we need is that line over there, nothing else. If you want to see the docs, you have the docs down there. Let's try it. Let's go back again. Exercise 4. Okay, so let's try to do this one. We have this one. We have an extra step that actually doesn't have a comment or a to-do. Right up there, we have something related to the gateway, as you can see. And here we are going to try to load the image from our local daemon and directly from the gateway. So hopefully you already know how to build an URL for loading the content from the gateway. You have the hostname over there on the HTTP gateway variable, and let me just point here. The CID will be here. So here we need to build the URL for our content. So let's use this, this, and this. So here we have the hostname already filled in for us, and what we need is basically / IPFS and the CID, nothing else. Right? So as you can see, everything is in there. Let's try to see if we can just load. So we did the same as last exercise. We added the file. Now let's try to load it directly. No, it doesn't work. Okay.
CID instead of ID.
Oh, nice. Let's see. And close. But we're still missing something. We need to load it from our repo, right? And you can go into the link and see the options and how the cat command works. We're gonna do it really quickly here. It's just as the one before. Cat. We need to send it to CID. Save it, and hopefully it will work. Right? Okay, so did you manage to follow up until this point? Can you load the both images? Sometimes the gateway takes a little bit longer because it needs to figure out how to get to. Because the gateway, as you can see, is a public, our public gateway. Actually, when it loads this image, it first needs to go into the browser, the index.db of the browser, get all the blocks for that image, and then send us back the image. So it does the full circle. So. Okay, no question, no problems. Don't need help to get to this point. All good? Yes? Cool. So now we need a way to track updates by naming things, right? Of course we need. So this takes us to IPNS. We need a static name to the content path. IPFS is immutable, so if we change the content, this CID will always be different. So if you wanna do host your website in IPFS or something like that, if you change anything on your site, the CID changes. So how can we maintain a static name or a static pointer to our content. We're not gonna like hand out CIDs every time we change our website, right? So we have a naming system. IPNS, basically, we get IPNS slash the hash of our public key, which is basically a pointer to our content. You can also have readable names using DNS link, so we don't use any hash, and you can also get to the content. The API looks like this. It's name publish. When you publish, you want to publish a CID, and you get back IPNS path with the key ID. So this one is the mutable one, right? The CIDs and IPFS are immutable, IPNS is mutable. Basically a multiple pointer to immutable content. And when you want to resolve, you try to resolve your key ID, and you get back the CID. So what about, like, I want to publish different things, because this key here by default, if you don't set up anything else, is the key for your IPFS instance. When you initialize your IPFS instance, you create a pair of keys, and this one, without any further setup, is the hash for that key, for that public key. So we are gonna want to name more than one thing, right? So we have an API for that. We can generate several keys. We can name those keys, and then when you publish, you just pass in the name. And you can do multiple publishes, and you can have key pairs associated with each of the pointers to the content. So let's see if we manage to. We also will have deep dives on it today about it. So if you want to learn more about it, challenge number 5: updating a multiple pointer with IPNS. So again, really easy. Just the only thing we need is that line over there, nothing else. Let's go again into the exercise number 5. Okay. As you can see, everything that we did up until now is here. Right now, the only thing we care about is this last part. Try to follow on your editors. We only need this part. As you can see, we're gonna call the publishing part. So what we need here is to publish, and we need to publish the CID, and this CID will be in this variable. So we need to run the command, pass in the CID, and see what happens. You have the link, you can go and check the documentation. We're just gonna run the command, publish, hit the CID. Okay. So the output for the publish command is an object with a key name and another key value. And that is exactly what we need for this last part. This is the output that we want. We want to build this string with the name, which is our IPNS key, and the value, which is our CID. So I'm gonna do some destructuring in JavaScript. If you don't know what this is, don't worry about it. It's not the point of this talk to teach about JavaScript. You could just copy what's on the screen. Okay, we saved it. Okay, so now we're gonna do all the steps again. The objective at the end is that we upload our avatar here. We can see the avatar we just uploaded, and then we're gonna build our profile. We're gonna write our names here. We're gonna get the CID for the avatar in this box. We're gonna copy paste here. We can write something about us here, and then we're gonna add everything to IPFS. This form creates a little JSON, and then we add this JSON itself. And after that, we're gonna publish. And when we publish, we will show up here, right? Because this is the list of beers. And as I explained to you, when we publish, if we don't pass in any option, we publish as our default peer ID. Our key pair is our default peer ID, and we publish as our default peer ID. So we will show up, hopefully, in this side on the dashboard if everything goes wrong. So I'm gonna try. Maybe I'm already there. No, so okay, I'm gonna choose picture, the little ground. I'm gonna write my name. I'm gonna get the CID up here, copy, go down again, paste it here. I'm gonna hide where I come from, and then I'm gonna add to IPFS. As you can see, the JSON here is the data we are adding to IPFS. And now we get the CID for that data. The CID we don't need to copy paste it anywhere, it's hooked up already. We just need to click the publish button. And then hopefully, if we manage to publish, let's take some time. Let me see what is happening. Okay. I made it cool. I did something wrong.
Like values undefined.
Sorry, what?
Is value defined?
Value?
Oh, you could.
Oh, exactly.
Oh, yeah, you did it.
Thank you again.
So you can keep.
So now, yeah, hopefully it will work. We already see some of you there, hopefully. Again, if you have any questions to get to this point, raise your hand. You want to see all your avatars up there.
Oh, yeah.
Whoa, whoa, whoa.
Got it. Check.
Okay. Oh, yeah. And I'm already on my computer, on the dashboard, and hopefully on your computers too, alongside everyone else.
How does it calculate? Yes.
So, you need any help to get to this point?
Okay.
Yeah, yeah.
No? All groups managed to get to this point? Yeah?
Yeah, but our cat is not showing up.
So what?
Our avatar is not showing up on this page. Is this a like real-time update?
it can take a little bit.
Okay.
Do you manage to publish?
Yeah.
Yeah, we got.
Yeah. Yeah.
But is it?
Yeah. Just wait a little bit, and it will show.
Okay.
Sometimes. What?
Okay.
You can go back to the dashboard. And yeah, so if you have any questions now, nice one. Nice. I love that. Cool. So if you have any questions, we have some time now until we finish the, we have like 10-15 minutes. Any questions? We are here to answer.
Could you say what's happening here?
So, how does I had a look at the swarm function. Can you tell us a bit about what's happening? How does the swarm know our IP addresses? And
You wanna answer this one?
So I understand the question was how do we get addresses of other peers?
yes.
Yes.
Yeah. So basically, there's a command called swarm peers, which returns list of all the peers your node is connected to.
Oh.
And in this case, we did not code that, but if you look at the sources of the sample app,
I
it's
did
there.
find it.
Oh yeah, yeah.
More info about how the
Yeah.
swarm works.
Yeah, so the way we get those addresses is through that signaling server running in Jim's house.
Just restarting it. Just make sometimes gets stuck.
Because in the web browser we don't have DHT yet, so we need to use semi-centralized signaling servers.
Okay.
What's cool about our implementation is that you can have multiple ones. For the purpose of this course, we are using just one. That gives us this nice dashboard only of people who are here. Otherwise, if we would use the publicly available ones or use multiple ones, we would get like random people from the internet. So we had like a small subset just for this dashboard to be more to make it easier for your avatar to find it. But you can have multiple ones, and as long as at least one signaling server works, you will be able to connect to the network.
Thank you. That's helpful.
And in case if you are running like go-ipfs or js-ipfs daemon not in the browser but in Node, then you get those peers from DHT. You can also use signaling server, but if you have access to DHT, then you have like access to wider network.
Any more questions?
If you use the key generation instead of your ID, is that just on memory, or does it is actually stored somewhere that you can later recover?
Yes, it's source. And in IPFS we have a thing called what we call the repo. We have like several data sources for these different purposes, and one of them is to store the keys. And you, when you want, you have other commands in the key namespace that allow you to export or import your own keys. So you have full control of the keys you have there.
Are these keys any of these keys be used as for the peer ID, or like there is very specific one for the peer ID?
Lilac, do you know how many types of keys we support right now? We support like at least 2 or 3.
Yeah, there are at least 2. I think there's RSA is the default.
Yes.
And we also support elliptic curve one. You can change the type when you generate a new key. You can pick a type. You can also pick if it's like RSA. You can pick how many bits, stuff like that. And both like CIDs, multi-hashes, and also those keys are constructed in a way that you can switch in the future as new algorithms appear. You can transparently switch the new one, generate a new identity, peers will automatically be able to use that without the need of changing code too much. It's like self-describing. Peer ID that we could see on the screens, it was just multi-hash, which had a prefix which was self-describing. It told you what hash algorithm was used, and similar approach for keys is also in place.
Yeah, but the keys, you get the keys there. There's no like multi-formats. The stuff like I was talking about is about like the other types of representation, like string representations, like boolean. The keys itself, it's just the keys, the output of you are used to. You can after represent like the peer ID, which is or the IPFS ID, it's the hash of the public key, and that with those representations we have a thing called multi-formats that basically we encode all these types of information with a specific way, so we can upgrade in the future when new stuff comes up. Any more questions? No? Okay, so hope you liked it, and we will wrap it up. Thank you, guys.